Okay, cost of production includes all kind of expenditure which are incorporated to produce goods and services. So whenever we produce goods and services, we have to pay multiple costs, and these costs are divided into number one is fixed cost. It is denoted as FC. Fixed cost is the cost which we have to pay even output is zero, and it remains constant even output increases or falls. For example, we have to pay rent of the building irrespective of level of output produced. We have to pay insurance cost irrespective of output produced, and we have to pay interest if we got any kind of loan from the bank. So these costs are basically fixed cost, and fixed cost can be explained with the schedule and diagram. Let's say we have different levels of output and we have fixed cost in dollars. If output is zero, let's say fixed cost is $100. If output increases to 10, 20 or 30, fixed cost will remain the same, because if this cost is, let's say, rent, we have to pay rent even output is zero. We have to pay the same rent if we produce 10 units, and we have to pay the same rent exactly if we produce 20 units or we produce 30 units. And if we make graph, the graph will look like this. We can plot quantity on x origin point, and this is cost on y-axis. So the graph of fixed cost will be a horizontal straight line showing that fixed cost is $100, even output is zero, or even output is 10, even output is 20, or it is 30. So fixed cost is like a horizontal straight line. And coming to the next cost, that is average fixed cost. Average fixed cost is fixed cost divided by quantity produced. We can see that average fixed cost will continuously fall if we keep increasing our level of output. If we have output or quantity produced and we have some fixed cost, we can find average fixed cost. Let's say our output is zero, total fixed cost is $100, and if output increases to 10, fixed cost remains the same. Output increases to 20, fixed cost again remains the same. Output increases to 30, fixed cost remains the same. So average fixed cost, we can find average fixed cost by putting these values in the in formula. Let's say when output is 10 units, fixed cost is 100. 100 over 10 will give us 10. So average fixed cost at this level of output will be 10. And if we increase our level of output, every but fixed cost remains the same, output is, let's say, now 20 units and fixed cost was 100, so average fixed cost will be 5. And if we further increase output to 30 units, average fixed cost will fall to $3.3. We can clearly see that whenever we increase our level of output, average fixed cost continuously falls. And if we draw its graph, it will look like this. For example, we have quantity on x, origin point, and cost on y-axis. So average fixed cost curve will look like this. This is AFC. If output is 10 units, average fixed cost is also 10. If output increases to 20 units, average fixed cost will fall to $5. And if we further increase output to 30 units, then average fixed cost will further fall to $3.3. So average fixed cost is always negatively sloped and it continuously falls with the rise in output. Next concept is variable cost. Variable cost, as the name suggests, is the cost which keeps changing with the change in output. Variable cost keeps changing with the change in output. If output is zero, variable cost will also be zero. If output increases, variable cost will rise, and if output falls, variable cost will fall. So examples of variable cost can be, for example, raw material. If we produce greater volume of output, we will have to pay more cost of raw material. And if we hire more daily wages, then wage will rise. And If we use more electricity, then we will have to pay greater electricity bill. So these are variable costs. For example, if for producing 1 unit of a product, we have to pay variable cost per unit is, let's say, $5, $5 per unit. Then we can find total variable cost at different levels of output. If we have, let's say, output, and this is total variable cost. If our output is 0, variable cost will also be 0, because when we produce nothing, we will pay no cost. And if output is, let's say, 10, variable cost will be 50, because 10 into 5 will give us 50. If we further increase output, our variable cost will rise. If we further increase our output, our variable cost will further rise. So we can see that variable cost continuously increases with the rise in output. We can draw a graph to show this relationship. We have quantity on X, origin point, and this is cost. One thing is really clear, that when quantity is 0, variable cost will be 0. So graph will start from this point, from origin point, because when quantity is 0, variable cost must also be 0. So graph of variable cost will be positively sloped because of positive relationship between quantity and variable cost. When quantity produced is 10, variable cost is 50. When quantity increases, variable cost increases, and if quantity further increases, variable cost will further rise. So variable cost will be positively sloped, and it will start from origin point. One thing is really clear, that it will start from origin point and it would be positively sloped, but it need not to be a straight line. It can be curved like this. So variable cost may increase exactly with the same proportion with every increase in level of output, or it may increase with different proportions with every increase in output. If increase in variable cost is different, then it will not be a straight line. It can be curved like this. Average variable cost is denoted as AVC, and this is variable cost divided by quantity produced. So जब हम output produce करते हैं, तो हमारा average variable cost initially fall करता है. When we increase the level of output, average cost initially falls with the increase in output because of greater potential and availability of better machines initially, and then it reaches at minimum point. Afterwards, if we further increase output, then average variable cost will keep rising. When we increase output initially, this is quantity, is basically we can label it as output as well. So when we increase our output, average variable cost is falling. Why it is falling, we can have a look on it. And when output is Q, average variable cost is minimized. And if output increases more than Q, then average variable cost will start rising. Why average variable cost falls? Because initially, when we have certain machinery, technology, and tools which are really productive and they are not fully employed, and when we increase output, this technology, machinery, and tool is more productive to greater volume of output at relatively low average cost. But when it is fully utilized, it means our very average variable cost will be minimized. Afterwards, if we further increase output, it means we are overutilizing our machinery and technology. So it will require more repair and maintenance of machinery and technology and tools. So it will result in wastage of time and other resources. So average variable cost may fall, reach minimum point, and it increases with the rise in output. And total cost is the sum of fixed cost प्लस वेरिएबल. अब इसमें अगर हम देखें तो हमारे पास दोनों तरह की कॉस्ट आ रही हैं, और वी कैन मैथमेटिकली or numerically represent it as, let's say, fixed cost is $50 and variable cost is, let's say, 2Q. अब हम इसका जब ग्राफ बनाना चाहेंगे, so to draw graph of total cost, we have to keep in mind that graph of total cost will be positively sloped. However, it will not start from origin point because there is some intercept of $50 which is fixed cost, and graph will start from $50 and upward. Relations between these three costs, total cost, fixed cost, and variable cost. So we can write as relations among uh, total cost, fixed cost, and variable cost. अगर इन तीनों का हम relationship देखेंगे, then we can draw another graph. On x we have quantity, on y we have multiple costs, and fixed cost is like horizontal straight line like this, and this is, let's say, $50, and variable cost is like this. और अगर हम total cost को देखेंगे, then total cost looks like this. Okay. You have to keep in mind that the gap between total cost and total variable cost will remain the same. That's why these two lines are parallel to each other. Why the gap remains the same, we can clearly see it with this equation, that 2q is variable cost and this is total cost, and the cost in between these two costs is fixed cost, and fixed cost remains the same with each level of output. So if fixed cost remains the same, the gap between variable cost and total cost must remain the same. So that's why these two costs are always parallel to each. This intercept is fixed cost, and we can see what kind of tricks generally examiner use to confuse students. He draws different perpendiculars at different levels of output like this. For example, this is output Q1, this is output Q2, and this is output Q3. At Q level of output Q3, if output is 0, we can see that we can easily find fixed cost of $50. But if output is Q3, then what will be the fixed cost? Again, we can label this point as A, and this is, let's say, B, and this is C. So examiner may ask you find out the fixed cost if output is Q3. So fixed cost in this situation will be the gap between, like, if output is Q3, the examiner may use these variables to ask a question. So this much, yani B to Q3 is fixed cost, or it can be the gap from point A to point C. So gap between point A to C is also fixed cost because this gap is also equal to $50, as I mentioned earlier that the gap between variable cost and total cost is fixed cost. So these gaps between total cost and variable cost are also fixed cost. This is also fixed cost. This is, suppose करें F and G. The gap F and G is also fixed cost, and the gap G and Q1 is also fixed cost. So examiner may use multiple tricks to confuse you. So you have to be clear that at any point, the gap between total cost and variable cost will give us fixed cost. Average cost or average total cost may be denoted as AC or ATC, and it can be calculated as total cost divided by quantity. And another formula to calculate average total cost can be fixed cost plus variable cost divided by quantity. Or another formula for this can be fixed cost over Q plus variable cost over Q. मैथ, आप लोग मैथ जीनियस हैं, आप लोग आइडेंटिफाई कर सकते हैं कि जो चीज़ें मैं सारी लिख रहा हूँ ये सारी सिर्फ ब्लरी हैं, एक्चुअली में सबका एक ही मीनिंग है. Or we can also write average cost as average fixed cost plus average variable cost. किसी भी चीज़ की average लेनी हो तो we just basically divide that kind of variable by only quantity. So if we are dividing fixed cost by quantity, FC over Q, that will give us average fixed cost, and variable cost over quantity will give us average variable cost. So average cost can be calculated by multiple ways, and then graph will look like uh, average variable cost, and its shape would be exactly similar to average variable cost, but there is a difference. So average cost also looks like average variable cost, and it is U-shaped. It initially falls reaches minimum point at output Q, and afterwards it starts rising. So this is the best situation where output should be stopped by the producers. They should not go for producing greater quantity more than Q. And average cost, as we uh, have seen, that average cost is equal to average fixed cost plus average variable cost. And we have also seen that average fixed cost is always negatively sloped, showing that if we increase output, our average fixed cost will fall. We took multiple numerical examples as well. For example, if fixed cost was 100, average fixed cost can be calculated as fixed cost over quantity. Fixed cost over quantity. This is average fixed cost. Hmm. If output is 10, average fixed cost is also 10. If output increases from 10 to 20, average fixed cost will fall from 10 to 5. So if output increases, average fixed cost will fall. And further, we have seen that average variable cost is U-shaped and average cost is also U-shaped. If both are U-shaped, then what will be the difference between average cost and average variable cost? We can clearly see it with another graph. And from this formula, we can also see that average cost is equal to average fixed cost plus average variable cost. And since average cost also includes average fixed cost, so it will be greater than average variable cost. And on y-axis, we can show cost. This is average cost. So average variable cost will be below average cost. Average variable cost is lower than average variable cost. And we have seen one different thing, that there is greater initially gap between average cost and average variable cost. This gap is continuously decreasing. Why this gap is continuously decreasing? It is because of average fixed cost. The gap between average cost and average variable cost is average fixed cost. And since average fixed cost always falls with the rise in output, so this gap will continuously decrease with increase in output. So this gap will keep falling. This is average fixed cost. This is also average fixed cost, and this is also average fixed cost. And if we draw a graph or line for average fixed cost, then it will look like this. Average fixed cost will be like this. The line of average fixed cost will be negatively sloped, or we can find average fixed cost, which is the gap between average cost and average variable cost.